is.
No one can know.
Okay, so
Eraser business.
chapter 3, of course, we start studying derivatives, and what do we start with? The limit, the definition of derivative. Okay, so we've already kind of touched on this, but I want to also give you the formal definition of a derivative, or how to prove that a derivative exists. Okay, we just kind of glanced over it last year by saying, well, if it's a quarter or a cusp or a discontinuity, well, I'm going to show you, like, mathematically how to show that's true. Okay, so Dylan, since you so aptly memorize things, what's the limit definition of a derivative?
I don't memorize
I might be able to
things. Short answer, I just don't.
We don't remember it long enough to do the test, right?
Yeah.
Do you need a new set of study cards, by the way?
I think
I think our color coding's going to be different, but...
You still have them?
I saw
No, we could deal with that. Anybody?
I need to bring mine.
I'll just take one.
Let it-
to
oh, wait.
Use the liquid.
Oh, plus H minus.
There you go.
Over.
Okay, there's one. What's the other one?
The limit as x approaches a, f of x minus f of a over x minus a.
Okay, you have to know those.
Isn't that
Right.
almost like the average rate of change?
This is the average rate of change, but we put it on a limit so that when you have, thanks for asking that, 2 points, x and a, right? If x is approaching a, what's happening to these points? They're getting closer and closer and closer, right? Until they are the same. And what do we have when we have 1 point? Instantaneous rate of change. That's where this comes from, right here. Excellent question. This is very similar, except that we call this gap h. So h is approaching 0. The distance between the two is going to 0. So what do we have when we get to 0? The same point. So that's where they come from. Okay. Do you want me to go through a couple of examples here, or do you think you got it?
Well, you're pretty much just finding the function and deriving it, right?
Yeah. You pull out the function, calculate the derivative. You might have to plug something in, right? Are we good with that?
Pretty self-explanatory. I just need to know where to get that.
So here. What's the function? That's the derivative. The function's x squared, right? I know this one's easy. I know you want to bounce right to the answer, but when they get more difficult, it is nice to write them down.
But
In this,
for FRQs, you get points for rating all that.
you do, yeah. So, but I doubt you'll see this in a free response.
It could be already here in the
If you do, that would be nice.
Well, we get like a super easy FRQ and then like the next.
We saw this, I think, in a warm-up yesterday, or 2 days ago. Not 2 days ago, because we weren't here.
Pretty sure it was on the
Same problem, right? So the derivative, or the function x squared, derivative 2x. Okay. What if this
I think you could go straight to do that.
That would really
is the problem? There are 2 ways to approach that one. Who's just going to do the limit and factor? That's probably what I would do, right? But that's also a limit definition. A is 1, right? So f at 1 is 1. So you are pulling out f of x is x squared. the derivative is 2x, and then analyze it at 1. F of prime at 1 is 2. Okay, so we recognize those different forms. This one would look like this. We could also write it, that is the ugliest limit I've ever written, h plus 1 squared minus 1 over h. A little bit more nebulous in that case, right?
Wait, so with the first one, how are you supposed to find out what the actual equation is?
They would say f of x equals
Oh, okay.
x squared.
Yeah, okay.
And then it would give you this. Calculate this limit. This is probably how you would see it. That needs a little bit more analysis, but still doable. Okay. All right. When does a derivative exist? So we're going to talk about existence today. It's one of those questions that baffles us in life.
It's magic.
It's magic.
What's wrong with that?
That's how I wanted eyesight to work. I found out that it's like just light reflecting back in your eye. You see nearly as
It's not just that.
I know, but that's
Let's not talk about the electrical impulse that has to go to your brain. It has to be interpreted, and then you have to realize that it was interpreted, and then you have to think about it.
Your brain actually being.
Let's not talk about the fact that it takes 21 mutations all at once to make the eye, which is an argument against evolution in my opinion. But hey, we're not in biology right now. So, when does a derivative not exist?
When we say it's
Okay, so we can do a cusp.
Any reason on the side is too hard.
We got our bird function, right?
We're talking about when it does.
I used to draw birds.
Does
like
not.
that, so,
When
side is too hard.
yeah, it's an art class.
a derivative does not exist. Yeah. Okay, corner. Discontinuity.
No, I was giving another example for something, so I wasn't saying that.
Any type of discontinuity, really. I mean, we could do that as well, right? You could do it infinite. Okay, so 3 situations I just taught you last year to recognize. You better recognize foo, right? The derivative doesn't exist. What function is that attached to? Something like this. It's a 2. The squared makes it positive in both directions. The cube root. This is like the absolute value of the cube root would be just about the same. But it's not. Okay, how about this one? We know we could do this, right? And those are piecewise, usually. Right? How would I prove this in terms of calculus, that these are discontinuous? Now prove it. Before I just let you kind of say, yeah, it's not, the derivative doesn't exist because of
Well,
this.
if they're custom corner, you can draw infinite amount of tangent lines
Yeah.
on it.
That doesn't prove it.
Why? What?
Put it in and then you do a correct statement.
Yes.
You gotta show the
Okay,
local-
so what could we do at this one
Wait,
to show that that derivative does not exist?
It's not locally limited.
we could just prove this.
Prove it's not continuous. Okay, that one's pretty straightforward. So what do you know then? It has to be continuous, right? These are continuous. But what is not happening? So let's think about this. If I take some curve and I ask for the derivative at that point, it exists. Do you agree? Just looking at the picture. Okay, it's continuous, right? So we have continuous. Check. What is happening each of these directions? What's happening to the tangent lines as we move closer to this point? They're coming to the same slope, right? So in calculus terms,
So basically the corner in the cup, because the slope is changing immediately, doesn't.
right? So the slope coming from the right is different than the slope coming from the left. How would we put that in calculus terms?
Isn't that enough?
The limit of the derivative exists. Okay. So this is how we go. One way to prove. Okay, this is one way to prove that a function is differentiable or not differentiable. Okay. So let's look at f of x equals the absolute value of x at x equals 0. We know it's not differentiable because there's a corner, right? Prove it. Or disprove it.
So, the function is x equals 0 from the right does not equal the slope of the function that
That's in words, that's exactly what you need to do. Okay, so this is continuous, we know that, right? So we can just ignore that. What is the derivative? Piecewise.
So if the derivative is a piecewise function that doesn't.
What is the limit as x approaches -1? No, sorry, 0. Let me get that straight. From the left of f prime of x. Yeah, -1. And the limit as x approaches 0 from the right of f prime of x is 1, right? Oops. The limit of the derivative, man, I am having a rough time here, does not exist. So we're not differentiable.
So you're basically proving continuity on the.
Continuity has been, is proven, obviously, but we are showing,
Well, continuity is proven on the graph f of x, but f prime of x is not.
Right.
The limits aren't approaching.
okay, so that's the second way to do this. Okay, no, you got a good point. So one way is to prove continuity on the function and then use the derivative limits, right? Or method 2 is just to show f prime of x is continuous. That's your other method. See, f prime of x is not continuous in this case, right? So you have two different ways to show differentiability, or to not show it, right? Questions? Do you want me to come up with another one?
Yeah, I'm doing a harder one.
A harder one. Let's see if I can come up with one on my... What?
I'm so proud, so glad we do like 3 weeks of school. I felt that way after the first day. Did we all?
Let's try this one. And we'll do it at x equals 0. I think is where we're going to have issues. So which one do you want to use? Continuity plus limits or just continuity of derivative? Okay, so we're going to say prove f prime of x does not exist using the derivative continuity. So what is f prime of x? I again rewrite it 2 over 3 cube root x. Right?
Well, f prime of 0 doesn't exist.
Yep. F prime of 0 doesn't exist. Therefore, f prime of x does not exist at x equals 0. Well, that's easy, right? Okay, so that's all you need on this one. Donezo. Okay. What if we were to use the left and right limits? What would that look like? Think about, I'm plugging 0.001 in here, negative 0.001, right? Cube rooted, it's still a negative. So you get like negative 0.003, really big number, right? Now plug 0.000001 in there. Do I get a bigger number? The fraction's smaller, so the whole thing's bigger, right? So what are we approaching? Negative infinity. Because the graph is going like this. It's getting steeper and steeper. No. That's not what I wanted to write. Conversely, from the right side, what are we going to get? Positive infinity, right? So does the limit exist? No, it doesn't. Okay, so. Okay. So, there you go. A little bit cleaner on this one. You're not going to see this very much this year, right? Since I know a lot of you you're all going into science careers, I would assume. There's only a couple of you I don't know about. this might come into play when you're in like Calc 3, right? So I'm just kind of trying to prepare you for that, but I would not say this is going to be an AP exam. Okay, so just a little bit extra. But it's not hard. You just take the derivative, show it's continuous, right? So,
I think that might be like.
Okay.
I'm listening for Mr. Owens, like, this is going to be up to
Yeah, no kidding. You're like, surprise! It's actually not in the course description. The AP course description. And to be honest with you, I did not learn this until like last year, 2 years ago. I didn't even learn it in college. So, yeah, just show the derivatives continuous. So, I guess I probably show it to you because I think it's interesting. It's something I learned. But, that's what this sheet says. Oh, here we go again. Spiraling comes to play. Yeah, so summary, be able to use the definition of a derivative for AP exam purposes, but in addition, showing the derivative exists using continuity in those simple terms.